All right, so we're going to use L'Hopital's here. Remember, in order to get L'Hopital's, when you just do a normal evaluation of the limit, so when you plug in a 1, you need to get like 0 over 0 or infinity over infinity. Or there's some other exceptions, but basically some indeterminate form, okay? On this one, if you plug it right in, you do not get that. So if I plug it in as is, you would get 5 over 0 minus 5 over undefined, basically. No, 5 over 0, my bad. Natural log of 1 is 0. So that's not really indeterminate because we have some value over 0. So what we need to do, we can't use L'Hopital's yet. So what we need to do is we need to rewrite this in some way so that we can use L'Hopital's. So I think what we want to do is get common denominators here. So let's rewrite this with common denominators. Oh, not negative 1, positive 1. And this would be 5 times x minus 1 times ln x over ln x minus 5 times x minus 1 over x minus 1 times ln x. Okay, so let's come down here. So what is that? That's really like saying the limit as x approaches 1 of 5 ln x minus 5x minus 1. And I'm not going to distribute that. You'll see why in a second. This makes it simpler. Over x minus 1 times ln of x. And now if I was to evaluate this limit, what would I get? I would get 5, the natural log of 1, minus 5, 1 minus 1. Well, and then this is all over 1 minus 1 times the natural log of 1. Okay, well, that's a 0, that's a 0, that's a 0, that's a 0. So 5 times 0 is 0, 0, 5 times 0 is 0. Okay, so now we're getting 0 over 0. All right, now it's in determinate form. So now we can use L'Hopital's, but only now that we have written in this form, okay? That's important to take note of. So what we might want to do is, now I could distribute this, but I want to remember that that's a negative 5 that I'm distributing. So 5 ln x minus 5x plus 5 over x minus 1 times ln x. In fact, actually, I'm going to distribute this too. I think I'll just make it a little bit easier. So I can think of this as x ln x minus ln x. Just because to use L'Hopital's, we're going to take the derivative, and I think it's going to be easier derivative to take. Okay, so we know that L'Hopital's can be used here now that's in this right format. So let's go ahead and do it. To use L'Hopital's now, I'm going to take the derivative of the top, which is simply 5 over x minus 5 plus 0 over, I have a little tiny product rule here. Derivative of the first is 1 times ln x plus x times the derivative of ln x, which is 1 over x, and then minus the derivative of ln x, which is just 1 over x. Okay, this is just a big old 1x times 1 over x. And now let's plug it in again and just see what we would get. On the top, I would get, right, if I plug the 1 into here, I basically get 5 minus 5 plus 0. So I do get a 0. On the bottom, what would I get if I plug the 1 in? Well, that's a 0. Because natural log of 1 is 0, so that's a big 0. That's a 1 minus 1 over 1, so that's a 0. So I'm still getting indeterminate. So it looks like what I need to do is do L'Hopital's again. No big deal. That's easy enough to do. Let me zoom it a little bit out so I have some more space to work here. So you can hear my wife yelling at my sons in the background. So I'll do another color for another version of L'Hopital's here. Let's rewrite some of this actually over here. I could think of this top. If I rewrite this top as the limit, so that's easier to take the derivative. This is like 5x negative 1 minus 5. And down here, this is just ln x plus 1 minus x to the negative 1. Just like to think of that when I go take the derivative. It just helps me like visualize what I'm doing here. So the first derivative on the top is just simply negative 5x to negative 2. And then the derivative of negative 5 is just 0, so that one's gone. On the bottom I have 1 over x. The derivative of 1 just disappears. And then here I have a negative times a negative. So that turns into a plus 1 x to the negative 2. Okay, and just I like to rewrite now back in a different form, just because it helps me think about what this is. This is really negative 5 over x squared, all over 1 over x plus 1 over x squared. All right, now let's go ahead and plug in our 1 again. Let's see if we can do direct substitution again. Plug in a 1. If I plug in a 1 here, that's a 1 squared. That's negative 5 over 1. Hey, that's a value. Look, we might be getting somewhere. Oops, I hit the highlighter. Negative 5 over. If I plug in a 1 here, that's just a 1. If I plug in a 1 here, that's another 1. So 1 plus 1 is 2. And I think we have an answer here. Negative 5 halves. All right, I hope that helps.